Welcome to Learn with Roblox. In today's video, we're going to cover geometric sequences. Our first problem says we have the sequence 1/9, 1/3, 1, 3, and it goes on, and we need to find the sixth term. So here's what I'm going to do to find the sixth term. I'm going to show you the formula for a geometric sequence. So it goes like this. It says a of n, where a of n is the term you want to find, is equal to a1, which is the first term, times r, which is the common ratio, to the n minus 1 power. N is the term you're trying to find, which in this case is the sixth term. So what we need to do is find a1, r, and n, and we can solve for the sixth term. So what is a1? Well, that's the first term in this sequence. And what's the first term? It's just 1/9 because it's first. So a of 1 is 1/9. Now what is r? R is the common ratio, and what it means is how much are you multiplying by each time. So from 1/9 to 1/3, 1/3 to 1, and 1 to 3, how much are we multiplying by each time? Well, if you just take a look at it, you might realize that is just times 3 every time. Because 1/9 times 3 is 1/3, 1/3 times 3 is just 1, and 1 times 3 is just 3. And if that wasn't obvious, what you can do is take a term and divide it by the preceding term. So for example, I could do 3 divided by 1 to get 3. I could do 1 divided by 1/3. If you do that, that's also 3. Or I could do 1/3 divided by 1/9, and that's also 3. And these are all ways of proving that our common ratio is just 3. So let me just write that down. R is equal to 3, because we're multiplying by 3 each time. And then what is n? That's the term we want to find. And that's pretty simple. I told you in the problem, we want the sixth term. Therefore, n is just equal to 6. Now let's use these values and solve for the sixth term. So we'll have a of 6, which is the value of the sixth term, is equal to a1, which is 1/9, because that's our first term, times r, our common ratio of 3, and then to the n minus 1 power. Well, n is 6, so is the sixth, or 6 minus 1 power. So all we need to do is just compute this. Let's use order of operations first. First, we need to do exponents. So 6 minus 1 is just 5. And then we need to do 3 to the 5th power first in the order of operations. So if you do 3 to the 5th power, take out a calculator and do that. That is 243. And finally, just do 1/9 times 243. If you do that, you should get that the answer is 27. So that means that the sixth term is equal to 27. So I'm going to write equals 27 here. And then that's it. And then let me just show you another easier way you can do this, because this problem is more of a simple example. So in this example, notice that we are given 3, which is the fourth term. And the thing is, the fourth term is not that far from the sixth term. So if you want to do, what you can do is you go from 3 to the 5th term. I'll just write down this is the 4th term. And from there, you could go to the 6th term. And because this is an easy problem, you could do this without any issues. Whereas for other problems, you might have to use the formula. But I'll show you how to use this easy method for this simple problem. So we know that the common ratio is times 3, right? Because r equals 3. So just do 3 times 3, which is 9, to get the 5th term. And then just do times 3 one more time to get 27. So that is another simple way you could have done this problem if you didn't want to use the formula. Although in some problems, you might have to use the formula. Let's go to the next problem. In this problem, we have a geometric sequence that goes as 125, 25, 5, and then we need to find the 5th term of this sequence. So to find the 5th term, let me write down the formula for a geometric sequence. So it goes a of n, where that's the term you want, or the value of the term you want, is equal to a1, the very first term, times r, the common ratio, to the n minus 1 power, where n is the term you want. And let's find a1, r, and n. So a of 1 is pretty easy. What's the first number I gave you in this sequence? That's 125. What is r? Well, on visual inspection, you might realize it's 1/5, but let's say you can't figure that out instantly. What you can do is take any term and divide it by the preceding term. So for example, I can take 25 and divide it by the preceding term, which is 125. And if you do this on a calculator, you should get 0.2, which is the same thing as 1/5. Or you could also take 5 and divide it by 25. And you might realize that this cancels out to get 1/5, which is the same as 0.2. So that's how you can find the common ratio if it's not always at first. Take a term and then divide it by the term right behind it. And this will always give you the common ratio. So I'm going to say r is 0.2. You can also write it as 1/5 if you wish. It doesn't matter too much since they're the same thing. And then what is n in this problem? Well, I just said we want the fifth term. So n is equal to 5. Now let's put in these numbers and solve. A of 5 is equal to, let me just rewrite that 5, is equal to 125, because that's the first term, times r is 0.2, we calculated that, to the n minus 1 power, well that's 5 minus 1. And then now we can just compute this. So 5 minus 1 is just 4. Now we need to do 0.2 to the fourth power. I'll take out a calculator because that's not very easy to do in your head. So if you do 0.2 to the fourth power, this is equal to 0.0016. And then you just need to do 125 times 0.0016. If you do that, you should get 0.2. So 0.2 is the value of the fifth term. And you are done with this problem. It just happens to be a coincidence that the fifth term is also equal to the common ratio. The fact that they're the same thing doesn't mean anything. That was just pure coincidence in this problem. But the answer is 0.2. And then because we only had to value the fifth term, let me show you how you could have done this pretty easily as well. So what you could have done is started from the third term and worked to the fifth term. So what I'm saying is that 5 is the third term. You just go to the fourth term, whatever that is. And then from there, you could work your way to the fifth term. And because we only have to go from third term to the fifth term, this is not that hard of a problem to do. So remember, we have to just multiply by 0.2 each time. If you do 5 times 0.2, you get 1. If you do 1 times 0.2, you'll get 1/5, or 0.2. They're the same thing. And that's another way that you can get the answer of 0.2 for the fifth term. Let's go to the next problem. In this problem, we have the sequence 4, 6, 9, and we need to find the 12th term of this geometric sequence. Let's write the formula for any term in a geometric sequence. A of n, the value of the term you want, is equal to a1, the first term, times r, the common ratio, to the n minus 1 power, where n is the term you're looking for. Let's find a1, r, and n. a1 is just equal to 4. That's the very first number in this sequence. What is r equal to? Well, right now, it's not very obvious to tell what r is. So what you need to do is you need to take a term and divide it by the term right behind it to find the common ratio. So let's start with 6. If I take 6 and I divide it by the term right behind it, which is 4, I'll get that this is equal to 1.5. So that is my common ratio. So r equals 1.5. And to prove this again, let's just do this with 9. You take 9 and divide it by 6, which is the term right behind it. 9 divided by 6 is also 1/5, or 1.5, sorry. So this just shows that the common ratio is 1/5, or sorry, 1.5. I gotta stop saying 1/5. And then n is just equal to 12, since that's what I told you to find. I said find the 12th term. Let's plug this in. So a of 12, that's the value of the term we want, is equal to 4, our first term, times our common ratio is 1.5, to the n minus 1 power. That's just 12 minus 1. So now just do 4 times 1.5 to the 11th power. And then 1.5 to the 11th power, you will definitely need a calculator for this one. And if you do that, that is equal to 86.497 roughly. The decimal goes on for a lot, but I'm just going to truncate it here. And then do 4 times 86.497. If you do that, this is actually roughly equal to 346. I think the actual answer is like 345.9 something, but I'm just going to round it up to 346. If you get this on a test, follow whatever guidelines your teacher has for rounding, but I'm just going to round it to the nearest whole number. So a of 12 is equal to 346. So I'm just going to say equals 346 up here. And that is the answer. In this problem, you have the geometric sequence that goes as -3, 6, -12, and it goes on, and we need to find the 9th term. So let's just write down the formula for a geometric sequence. a of n is equal to a1, which is the first term, times r, the common ratio, to the n minus 1 power. N is the term we want. A of 1 is just the first term in the sequence. That's minus 3. That's the first number I wrote in this sequence. R, to find r, what you need to do is take a term and divide by the term right behind it. So I'm going to take 6, for example. Take 6 and divide it by the term right behind it, which is minus 3. 6 divided by minus 3 is equal to negative 2. Therefore, r is negative 2. So don't be intimidated by this. You can have negative common ratios, and that's okay. And then just to prove this again, I'm going to take minus 12 and divide by the term right behind it, which is positive 6. Minus 12 divided by positive 6 is equal to negative 2. So there's just more evidence that the common ratio is negative 2. So we're multiplying by negative 2 each time. And then n is just equal to 9 because I want the ninth term. Let's use these numbers to compute the ninth term. So a of 9 is equal to a of 1, which is negative 3, times the common ratio is negative 2. And then n minus 1 is just going to be 9 minus 1. And let's compute this. So we'll have negative 3 times negative 2 to the 8. 9 minus 1 is 8. So now you can just take out a calculator and do negative 2 to the 8th power. And I just want to make a note of this. When you type this into your calculator, make sure to put a parenthesis around the minus 2. So put this into your calculator. If you put this into your calculator, you might get the wrong answer, because the calculator will do this first and then put the minus at the end. But we need the minus to go into that exponent, or else we'll get a different answer. So make sure you put it like this into your calculator and not like this. But if you do that, what you should get is that you'll have minus 3 times negative 2 to the 8th power is 256. And then if you do negative 3 times 256, you should get that this is equal to negative 768. So this is the value of the ninth term. And just like that, we're done with this problem. So I'm just going to write this here as well. The value is negative 768. Let's move on. In this problem, we have the geometric sequence that goes as 100, negative 80, 64, and we need to find the 8th term of this geometric sequence. So let's just write the formula as always. A of n, the value of the term you want, is equal to a1, the first term, times r, the common ratio, to the n minus 1, where n is the term you want, power. So let's define a1, r, and n. a1 is the very first term I gave you in this sequence. That's just 100. R is equal to the common ratio. How do we find the common ratio? What you need to do is take a term and divide it by the term right behind it. So I'm just going to do negative 80 and then divide it by the term right behind it, which is just 100. So if you do negative 80 divided by 100, well, those zeros cancel out. You get negative 8 over 10. If you do negative 8 over 10, that's just negative 0.8. So this is our common ratio. And I'm not going to do it right now, but to prove to yourself that the common ratio is actually negative 0.8, you can do 64 divided by negative 80, the term right behind it, and you will also get a common ratio of negative 0.8. So now let's solve for hold on, I need to define n first. N is just equal to 8, because that's the term we want. We want the 8th term. So now let's find the 8th term in the sequence. So a of n, or a of 8 actually, is equal to a1, the first term, which is 100, times our common ratio is negative 0.8. And then we're raising this to the n minus 1 power. That's going to be 8 minus 1. And 8 minus 1 is just 7. So raising this to the 7th power. So first do negative 0.8 to the 7th power. If you do that, you should get this is equal to roughly negative 0.21. It's not exactly negative 0.21, but it's pretty close. I just rounded it. And once again, on a test, follow your teacher's rules for rounding decimals. And then 100 times negative 0.21 is negative 21. So the answer is approximately, let me just replace these equals with an approximation sign. The answer is approximately negative 21. So negative 21 is the 8th term. I'm just going to erase this question mark here and put in negative 21. Or I'll make these approximation squiggles. And just like that, we are done with this problem. In this problem, we have that a ball loses 30% of its height per bounce. If it starts at 10 feet high, how high will it jump after its 8th bounce? So what we can do is we can actually model this like a geometric sequence. So here's how I want you to think about it. This ball is going to start at 10 feet. So that's like the starting term. Let me just write feet. And then after the first bounce is going to reach a certain height. And after the next bounce is going to reach a next height. After the next bounce is going to reach another height. So on and so forth until you get to after the 8th bounce is going to reach a particular height. So let me just write down these bounces. I'm going to call this bounce 1. I'll just call it B1 for bounce 1. I'll call this B2 for after the second bounce. B3 for the third bounce, so on and so forth until the 8th bounce, which I'll call B8. And I want to be careful with the terms here. After the first bounce, notice that you get the second term. After the second bounce, you'll have the third term because 10 is the first term. After the third bounce, you'll have the fourth term. So if we continue this pattern, after the 8th bounce, what term will we be at in this geometric sequence? We'll be at the 9th term actually. So be careful. And then now, how else can we model this like a geometric sequence? Well, we need to know what the common ratio is each time because geometric sequences have a common ratio. So we said that we lose 30% of the energy on each bounce, or 30% of the height rather. So if you lose 30% of the height after each bounce, how much percent of the height do you keep? Well, think about it like this. If you lose 30% of the height, you're going to keep 70% of the height. So in other words, you keep 70% of the height that you had on the previous bounce. So in other words, the way you can think of this is you'll have 10 feet and then you're going to keep 70% of it. And you'll keep 70% of it again. And you just continue to keep 70% of it until you reach a very small value, in which case the ball would probably just realistically stop bouncing in a real world problem. So now if we do 70%, 70%, 70%, what is the common ratio value? Well, what you can do is you can take 70% and convert it into a decimal. Remember, to convert a percent into a decimal, take that percent number and divide it by 100. So 70 is the percentage value divided by 100. If you do 70 divided by 100, you get 0.7. So in other words, 0.7 is our common ratio. So now let me summarize everything we have learned. We know A1 is 10 feet because that is the first term in this problem, is our initial bounce height. R is 0.7 because we keep 70% of the bounce height, or in other words, 0.7 times the bounce height. And N is equal to 9. So be careful. The 8th term, or the 8th bounce, leads to the 9th term. So we need to find the 9th term. So let's set up the formula. Let me just rewrite it. A of N is equal to A1 R to the N minus 1. A of 1 is 10 feet. I'm not going to write the feet. I'll just write 10. R is 0.7. And then N is 9. So we have 9 minus 1 as the exponent on 0.7. So now do 0.7 to the 9 minus 1 is just 8. So do 0.7 to the 8th power on a calculator. If you do that, you should get that this is equal to 10 times, let me just flip my page on my notes, 0.058 approximately. Once again, I just rounded this, follow whatever guidelines your teacher has for rounding decimals. And then just do 10 times 0.058. If you do that, you should get 0.58. And the units on this problem were feet. So that is the answer to our problem. So after the 8th bounce, we will reach a height of 0.58 feet. If you enjoyed this video, please like and subscribe. Thanks for watching.